What's going on, everybody? This is our data logging computer powered by a Raspberry Pi 3. We also have a Raspberry Pi Sense Hat, and we also have a 3.5-inch display screen. Attached to the Raspberry Pi, we have a USB to OBD cable and a U-Block 7 GPS. We also have a wireless keyboard and mouse to control the Raspberry Pi.
After using Noobs to set up our Raspberry Pi data logger, we used the tutorial on GitHub to install the software from the MaxBoost Git repository.
The first command that we used to collect data from our runs was the senselogger 3092 command. Once we started running it, the GPS was set to 10 Hz and we were collecting GPS data. And then to begin logging using the Sense Hat, we would use the joystick to toggle up. The light would turn blue to show that we are in fact collecting data from the Sense Hat, and then when the joystick is toggled down, the logging stops. Initially, when we ran the senselogger 3092 code, we kept receiving an error saying that the evdev directory did not exist, but after checking online, we found out that the command pip install evdev solved all of our issues.
The second command we used to collect data was the OBD GPS log 18 command, which collects data from the OBD and the GPS sensor. And when you run this code, it will collect data from the GPS, but as you can see, it's throwing an error for the OBD2 because we're not connected to a car right now.
This is how we had our data logger positioned in the vehicle. We had our GPS sensor duct taped to the dashboard and OBD cable connected. One issue that we ran into mounting the Raspberry Pi and the Sense Hat to the board was that the Sense Hat was able to move around in the vehicle. We tried to make the Sense Hat as level as we could and keep it in a pretty consistent position, but unfortunately it was able to move around during the runs, giving us some inconsistent data.
After coming back from the track, we opened up some of our log files on Megalog Viewer, and this is one of the passes. The red line is RPM, the white line is miles per hour, and the green line is the throttle. And the RPM, as you can see, started out around 3,500, 4,000, and off the line you can see it bogged down some. And this is as it accelerated through first gear. This is change into second gear, this is second gear, and this is switching to third right before the finish line. And there's a slight acceleration in third, and then right here, as you can see, the throttle drops off, and this is where I crossed the finish line and started slowing down. The max speed is right at the finish line, and as you can see, it's 91.36. which closely resembled the time slip that I got for this pass. A change we made for the second run on the Corvette was we turned the traction control on. On the first run we had the traction control all the way off, and so this is the second run where at the launch the car bogged down more from the traction and cutting power, and this is where it bogged, and then this is first gear, second and third, and this is the finish line right here. And as you can see, the trap speed's slower on this run because it bogged down more on the launch.
This is the data collected from my Nissan Xterra. As you can see, is quite a bit slower than Hunter's Corvette. We have on the white line, we have the GPS recorded miles per hour, and the red line is the RPM collected from the OBD cable. You can see the start of the race here around 20 seconds into collecting data, and you can see I hit 60 miles an hour around 7.5 seconds and up to a whopping top speed of 76.48, which closely resembled the 76.51 miles per hour that I received on my time slip. This is the data collected from the Sense Logger 3092 code. We have the GPS speed data plotted on the white line, while we have the gyros for the X, Y, and Z axis in red, green, and yellow. And as you can see, we have a lot of noise from the gyros, and that would be from the Sense Logger moving around inside the vehicle because we didn't have it fixed inside. While we were able to collect data from both the Sense Logger 3092 and the OBD GPS Log 18 codes, we were only able to collect usable data from the OBD GPS Log 18. If we were able to repeat the experiment, we would fix the Raspberry Pi and the Sense Hat somewhere in the vehicle to get more consistent data.